G'day. One of the guys at work heard that I did a little bit of machining in my spare time, and so he asked if I could make some spare parts for him. Oh, sure, I said, not a problem. And then he pulled out these. This one's a diesel type engine, and this one's a glow plug engine. But on both of them, the carburation had broken, snapped. I don't know whether it was he'd picked these up second hand and they were broken already, or what the story was. But the task was to make up new carburetor screws. And although they look reasonably straightforward, just the sheer size of them makes them rather interesting. So this is how I did them. This is the first one. It goes into a diesel engine. There's a flexible tube attaches here with the fuel. There's a very fine hole through there, and then there's a cross hole there, and there's a, for want of a better term, a throttle that pin that goes in the other side there, and the fuel comes out that hole. So I need to basically turn up at this outside, which isn't quite so bad, and then worry about the holes on the inside. That thread is a 4BA thread. Now, to give you a very quick and probably wrong history, prior to World War II, the British had three thread types. There was British Standard Whitworth, British Standard Fine, and there was also a thing called BA, British Association thread. It's got a thread angle of 47.5 degrees, as opposed to Whitworth with 55, and metric threads and UN threads with 60. It's a fixed size. There's 12 of them, ranging from around about 6 millimeters in diameter going down. But this is a number 4, and so I had to work that one out just through trial and error, really. I have a tap and a die for it, so that's not a problem. But the whole problem with this is it needs to be around about 1/8 of an inch longer. I started out with the thread there, and I've run the 4BA nut up there, so I'm happy with that. I now need to, and I've also come in and done the minor diameter there. I'm going to leave that cross hole till last, partly because I'm not quite sure what size it is just yet. The next thing is this slight step here. That has to be a decent fit in the motor casting, and then I'm back to the natural size here. So that's my next step. Once I've got that all done and I'm up to about there, I'll probably drill the hole in here, the through hole. The depth, from what I can tell, is important because that's controlling the rate of fuel feed. To tap that thread on there, as I said, I've got a 4BA die, but it's a 15/16 size die, and I haven't got this is the only stock I've got to hold that. So instead, what I did to make sure that was square was I used this wooden pad that I've made up, and that locates on the cone of the centre, and then with the back of the die flat on that, I was able to get that something resembling a square. It seems to have worked anyway, but that's another use for something like this. If you haven't got the die stock to fit in the tailstock, using that as a flat surface which you can then use to guide your die in is another option for you. One thing that is critical here is the hole sizes, and so to measure those, I'm using my set of pin gauges. Unfortunately, these only go down to 61 thou. I also have some letter drills going down to a size 60, but they only go down to 40 thou, 1 millimeter. However, I have remembered that I got some thread measuring wires, and while the steps aren't complete, there is a 32 thou and a 29 thou, and so I can measure things with that. And so based on that, I can get a 32 thou in that hole, so I'm going to assume that that's what it is, unless I can measure it more accurately, which I might be able to do. I'll have to check on that. The holes going down there, using the pin gauges, I get 70 thou, and that goes up to that hole, and this side it goes up to about there somewhere. This is the part that screws in there, and this is what causes the throttling action. And so it may be that has to be unsoldered and adjusted a little bit, but that's not my problem. However, that's 63 thou, and so I've got between 70 and 63 for this hole size, and I don't think it matters too much, what it is to do the throttling there. So I'm going to drill that now on the basis of 70 thou, which is one of the letter drills I've got, a 50 I think it is, and that'll basically get me up to about here minus that cross hole. I've reached one of those awkward spots, and I'll explain why. So far I've put the thread on there. There's a slight it's down to the minor diameter just after it, and then that fit for the going to the body of the engine. That's all fine. And I've also got the hole through there for the fuel metering pin, and as you can see, that goes on, so that's all fine. But the next bit that I've got to do, well, there's several things, and that's the problem. The options I have, I could put the flats on there. They're not parallel. They look like they've been put on by hand with a file, so that's neither here nor there. I can also put this bulb on here for the tube. Trouble is, as soon as I part that off, I've got nowhere really I can grab that to drill any holes, except possibly that bit there. Certainly drilling that hole in there is difficult, because there's nothing really to help locate and steady that part. I could possibly clamp down on that flat, but it's a little bit dicey because that's only a small diameter I'm drilling into. I'd like to drill I need to drill a hole in about there, which is about 70 thou, but there's also a very fine hole going through there, and if I put the flats on there, I haven't got anywhere to do that. Once again, I might be able to hold that there in a 3-jaw chuck and drill, but I have to think about that one. So I think for the moment, what I'm going to end up doing is putting on the bulb. If I can measure that hole to my satisfaction and I've got a drill bit, I might put that in there now so that I've got something I can really hold on to while putting that in. But these are all sorts of the sorts of things you need to think about when making parts like this, because if you get the sequence wrong, suddenly you discover you've got nowhere to hold on to it and you've got to start again. Another possibility would be to make up a threaded long nut or something like that, which I could then screw that onto and clamp, but that wouldn't necessarily be concentric and it wouldn't necessarily be all that strong. I need to mount the new piece that I'm making up in the vise to cross drill that hole. So what I've done is I've got the old one just set on a parallel, and I've got my microscope, and I'm just going to measure the diameter of that hole. It's probably about the most accurate way I've got of doing that. So if I line up the crosshairs on one side, zero the DRO, and then wind across, I can measure that. For those of you who haven't got one of these things, and once again this is another bit of kit that's becoming hen's teeth type stuff, a USB microscope is probably the modern equivalent, because I don't like computers in my workshop. I haven't got one of those here, but I do have this. So if you think that being able to measure something with your DRO is a good idea, USB microscope that you can use to zoom in on features, and then just wind with your DRO to find it. I measured the hole in the existing part, and it's just a smidge under 1 millimeter, 0.94. I haven't got a 0.94 drill, so I'm going to go with a 1 millimeter, 1.0, and that 50 microns will have to sort itself out. The way I'm going to drill this, though, I've got the DRO set up so that I'm over the spot where the drill has to go in. Now, if I put a 1 millimeter drill in here, I've got no quill, and so it'd just go crazy. So I'm going to use this. This is I've shown you this before, I think, but this is a sensitive drilling attachment. It's basically a sleeve with a grub screw that runs in a groove. there's a plate up here with a spring on it to do a spring retract, and this wheel here has got a bearing on it. And so what you do is you power up your drill or your mill or even your lathe, I guess, and that spins that, but the actual feed is controlled by you holding onto this knurled wheel and bringing it up and down. Okay, so that's a sensitive drilling attachment. Wouldn't be terribly difficult to make. I bought this one, but yeah, I've just got a small 0 to 3 chuck on here, and so I'll drill that cross hole, and then I can go back to shaping the bulb for the tube, parting off and drilling through without worrying too much about side forces on my piece of brass. I've put the bulb in there by grooving in there and then shaping that with a file. I then went back to the mill just to put the flats on. Nothing terribly special about that. What I now need to do is part that off, and then I'll mount that up in a 3-jaw using that little bit of material there. And the reason a 3-jaw rather than a collet chuck is I'd like a collet chuck, only I haven't got the grip length. So there's the first one done. So there's a 70 thou hole that goes from here up to there, and then another one from there to there, and in the middle there there's a 1mm hole. At least that's what I'm working on, same as that one. And that was probably the most nerve-wracking bit of that, because it's brass, it can grab, but seems to have worked, so very happy with that. So that's that one. The other one that I've been asked to do is one of these. This one's a bit simpler in that there's no holes or anything like that involved, but once again it's a long slender part, so I'm going to have to use the rule of thirds, for want of a better term, where you take off about 3 times the diameter and move along. The other complication with this one is that I don't know what that thread is, so I'm going to have to put that up on the mill, I guess, with the microscope and try and do some more measurements of that thread, because as you can possibly see there, it's been bent as it broke, and so that's distorted the thread a bit. There looks like there's a clean bit of thread on this piece here, so I'll just have to see what I can do with that. This screw I'm not expecting to be anywhere near as tricky, but it's still got some nasty bits to it, shall we say. For a start working at that thread, I finally came up with a number 348 thread, and I cut a test thread on a bit of brass here, and that seems to work, but a bit of trial and error to get there. The other thing is to get past this, what would you call that, knob, hand wheel, whatever. I'm going to need a specially ground tool, which I've already made. So I've got a tool there, it's got a 60-degree point on it, but it's designed to be able to get in there and give me a little bit of clearance, so I can come up to here and then pull out, go back and do that again. Now, as I was saying, I'm going to have to use what's referred to sometimes as the rule of thirds for this. And what that is if you're machining a slender bit of material, or you have to machine it down to a slender shape, you want to go a maximum of 3 diameters. Now the start of that screw is 1.6 millimeters, so I'm going to have a couple of goes at that to get that to, I think it's about that long, There's the first stage. That's 1.6. Actually, it's 1.58, but I'm not going to look too carefully at my calipers. So the next stage is I need a section about 10 millimeters long here, a little bit over, 2.5 for the thread. So that's the next stage. So that's now finished. I'm not going to touch that again. I've given it a little bit of a polish, but it's going to have to stay as it is, I think. At the end of this all, that needs to have a slight bevel put on there. And that thread is probably the trickiest part of this part, but as you see, the nut that goes on there fits on. I've come in and I've just put the knurl on. I now just have to take out that space between the two. After all that work, here they are. That's the original, and I've basically lengthened the screw by about 1/8 of an inch, 3.2 millimeters. Other than that, it's pretty much the same. This one here was bent and snapped halfway along the screw there, and so I've had to turn up a complete new screw and put that thread on. I've put the little chamfer, bevel, whatever you want to call it, on the end there. I eventually just did that with a linisher rather than tried to file it because holding it was difficult. But yeah, aero engine parts. So thanks for watching. See you for the next one.